Right, today we're going to look at composite functions. Now, most functions that we already know are a combination of one or two functions, which have just been simplified into a single function. So if we take, for instance, this example here where we say x is mapped onto 2x plus 5, well, this function could originally have been a combination of two separate functions. We could say that maybe this was the function g of x, which said take the variable x and multiply by 2. And then take the result of that and put it into another function. We can maybe call this function h of x. And the function h of x is take the result and add 5. So we could say that the result of this is the function is do g first, so multiply by 2, and then do h, add 5. So we create a composite of the two functions, right? So to show this in a flow diagram, we could start with a variable x, right? And the first thing we did is we applied the function g to it, which was multiply by 2, right? And this gave us g of x. And after that, we applied function h. And so we had g of x, which we applied h to. And if we wanted to go from one straight to the other, we would say we would say g h was applied to x, right? So one of the important things when we're looking at function notation is the way that it's presented to us. So if we have our variable, for instance, x, and we have h, and then we have g, right? We always start from the letter closest to the variable. So in other words, we're going to do h first. Once we've applied h, we're going to do g. So we start from the variable and we work to the left. Okay, not from the first variable. So we don't do g first, then h. That's not how it is. It's the opposite way. So let's look at some examples. So here we have a function f of x. They set a domain restriction that x is going to be greater than -2. And then they also say there's this function g. And here as well we have a domain restriction, x is greater than 2. And they say find fg of 7. All right. So what that means is we're going to put 7 into function g and then get a result and take the result of that and put it into function f. So let's do g of x first. So we're going to say g of 7 is equal to 2 times 7 plus 6 all over 7 minus 2. And the result of that's going to give us 4. So what we need to do now is we need to put 4 into the next function. So the next function is f. So we can say the f of 4. And that will be 4 minus 2 squared minus 3. And that's equal to 2 squared minus 3, which is 1. So fg of 7 is equal to 1. Now, sometimes we can be asked to create the composite function, right? So we won't be given a value to plug in. We will be asked to create the composite function. So it's very important that we make sure we look at the order. So these two functions might look similar at first glance, but they are not. in example A, we're going to start with G and then apply F. And in example B, we're going to start with F and apply G. In the final one, C, we have F squared. That just means apply F twice. So we're going to start with A, and in A we have G of X. So G of X is X squared plus 5. And what we're going to do is we're going to put G of X into F of X, right? So what we're going to say is we want F, right, of G of X. G of X is X squared plus 5. So everywhere we have an X in the function F of X, we're going to replace that X with X squared plus 5. So we have 2, right, and we're going to replace the X with X squared plus 5. And then we're going to subtract 1. Okay, we're just going to simply expand the brackets out. So we're going to get 2x squared plus 10 minus 1, which we can simplify as 2x squared plus 9. So that is our composite function f g of x. Right, B, we're going to do the opposite. So we're first going to think of f. So f of x is 2x minus 1, and we're going to put that into the function g of x. So g of f of x, so f of x is 2x minus 1. So everywhere we have an x in g of x, we're going to replace that with 2x minus 1. So we already have x squared here, so we're going to have 2x minus 1 squared plus 5. So this is basically our x squared plus 5 from g of x. Okay, from here we can expand the brackets out and simplify. So here is 4x squared minus 4x plus 1 plus 5, which can be simplified to 4x squared minus 4x plus 6. Okay, one more function to go. We're going to have f squared x, right? So that just means take f and put it into itself. So we're going to take the function f, and into the function f we're going to put itself. And expand and simplify. There we go. This can also be written as f of x. That's another way that you can see that being written. Okay, let's do some other types of questions that could be asked. So here we have question 6. We're given function h of x is x plus 2, and we're given function k, which is the square root of x. And they want us to express each of the following in terms of h and k. In other words, they are asking us to show what composite function has been created here. So let's have a look at A. Okay, so A, the result is x is mapped onto square root x plus 2. So you can see the first thing that's happening to x is it's being squared. Right, so if we go have a look at our functions, the function that squares first is k of x. So the first thing that's happening in this function is k of x. Right, after it's being squared, we can see that we're adding 2. And the function that takes x and adds 2 is h of x. And so after we apply k, we are applying h. And so the square root of x plus 2 could be the combination h k of x. And let's have a look at B. In B, we have the function x is mapped onto square root of x plus 2. So we can see underneath the square root, the first thing that's happening is we're having x plus 2. Right? And the function that takes x and adds 2 is h of x. And after we're doing that, we're taking the square root of all of that. And once again, the function that does that is k of x. K of x is the square root of the answer. And so in order to express this in terms of h and k, it would be k h of x. Right, another type of question that can come along is we are given two functions, and then we're asked to solve the function when the composite function is equal to something. So in this case, we're asked to solve the equation g f of x equal to 5. Now the first thing we need to do is create the composite function in order to solve. So if we look at this, we want g f of x. So that means we want to apply f first and then g. So f of x is 3x plus 1. And we're going to take 3x plus 1 and put it into g of x. So we're going to say g of 3x plus 1. So everywhere in the function g, everywhere there's an x, we're going to replace that x with 3x plus 1. So we have 10 at the top, divide by 2 minus, and here's where we're going to replace this x. Now this is a minus, so just very importantly, always put a bracket when you have a minus sign. 3x plus 1. Okay, let's just simplify the expression. We can get 10 at the top, and at the bottom we're going to get 2 minus 3x minus 1. So we're going to get 1 minus 3x. Now we have found what g f of x is. That's the composite function. And they want us to solve when this function is equal to 5. So we're going to replace g f of x with 5 and solve. So we'll say 10 over 1 minus 3x is equal to 5. We can multiply that 1 minus 3x up to the top. 10 is equal to 5 times 1 minus 3x. Expand the bracket out. 5 minus 15x. We can move things around a little bit just to simplify. So I'm going to move the 5 to the other side to get 5 equal to minus 15x. Divide through by 15. We'll get x equal to minus 5 over 15, which is 1 over 3. So that is the solution. Now we need to just go back and check whether our solution is valid. Can x be equal to minus 1/3? So if you have a look over here, this is the denominator. The denominator cannot be equal to 0. And we can do a simple check to find what value for x we cannot have. We'll move the 1 to the other side. So we'll have minus 3x equal to minus 1, x equal to 1/3. A third is not minus 1/3, and so our solution is valid.